Hey, it's Tony from Adafruit, and this is part 3 in the Raspberry Pi SQLite sensor storage series. And this is actually a day early, so normally I stream on Fridays with these kind of in-depth Raspberry Pi things, but tomorrow is a special day, so if you go to whitehouse.gov/live at 1 p.m. Eastern, you'll actually see Lady Ada featured in the White House Champions of Change ceremony. So I figured I probably shouldn't stream at the same time as that's going on, so we'll do this a day early. But this is the third part in the series, so check out when this goes up on YouTube. Down in the description below, I'll have links to the previous 2 videos. And it's really just been an in-depth look at how to use the SQLite database to store sensor readings. So thinking in the context of like you have some sensors connected to Raspberry Pi and you want to store that data maybe to analyze later, or in this video I'm going to look at how to build like a really simple little web application that can let you manipulate the database data. You can view it, maybe we'll even put like a chart on top of the data for it. So real simple, straightforward kind of stuff. But it's pretty interesting and pretty powerful. So hopefully you can kind of see like when you use a database, what interesting things you can do with it, why it's powerful and why it might be useful. So let's just kind of dive in. I'll show an example real quick of what I'm going to build in this stream, and then we'll just dive in and go through all of that. So let me switch to the main view here. And in the main view, so in the upper right corner, I have the Raspberry Pi. This is the Pi 3, but the model doesn't really matter. And I have 2 sensors connected to it, and this is just like the setup in the previous 2 videos. So I have a DHT22 sensor right here connected to pin 18, and then another DHT22 sensor. This is just a different type that fits into a breadboard like this, and it's connected to pin 25 on the Raspberry Pi. Both of these are just little low-cost temperature humidity sensors. Really easy to use those, so they just give you back a nice little temperature and humidity value using a little Python library that I wrote. And check out the first 2 videos. I have more details on like how to wire these things up and use them inside of here. But anyways, so the actual thing that I want to build is this web page right here. So this is a little Flask web application, and I've actually done some previous live streams on building simple little Flask applications, like the Pi Internet Things series, which was like one of the first kind of in-depth series that I did. But basically this is a Flask application, so it's a web application. Flask is a Python web framework that I like to use a lot because it's really simple and easy to get started with it. And it's actually pretty powerful. So like I've started this up and it's showing me a graph of both of my sensors. Now this graph is not updating in real time. That's maybe for a later video. So I have to refresh the page to see new readings. And it's only showing me the last minute of readings, but it's still kind of cool. And so if I blow on one of the sensors to increase the humidity, then we should see it increase. So let me just blow on this one real quick. And let's see how that changes things in a second here. And in the background, I'm actually connected my Raspberry Pi, and I've got a script running right here that's just like the script that I saw, or that we created in the last few videos, where it's taking sensor readings from both these sensors every 2 seconds, and it's saving them in a database. But then when I reload this web page, we'll see that it's actually showing me, hey, look at this, my humidity increased for this DHT1 sensor, which is this one right here that I blew on. And the other one increased a little bit because I think, my breath kind of hit that one also. But it's pretty cool. So you can see the database, the data is updating when I refresh the page here. Now there are a few other things on this page that I can see. So if I click this DHT sensor tab at the top here, this is actually pretty cool. This is showing me the data that's in my database. If you remember in the last video, we used the Pewee ORM, Object Relational Mapper, to create a table that stores all of the sensors we have connected to our Raspberry Pi. And so this is a really neat thing that we're going to look more at, how to build a little interface like this. And you might hear this described as a CRUD interface, or a create, read, update, delete. So those are kind of the common operations when you have like a database table. You can create new rows, or you can update rows, or read them, delete them, that type of stuff. And so there's actually all of that basic functionality here. Like if I wanted, I could create, a new sensor, give it a name like foo, the type, I'd have to pick the type, and I kind of need to know that it's a magic value like 22, maybe the pin it's connected to like 23, something like that. I could save this and it would add a new row to my table for that. I'm not going to do that because I don't have an extra sensor hooked up. But then there's also a sensor readings page in here too. So this is showing me the raw data in the database. And this is pretty cool. Like you can page through it all. You know, we can go to the end here and see these are the most recent readings that were written to the database. And so, you know, you can go through and go back some other pages here. So really cool, pretty powerful. And I'll show you, you might be thinking like, man, this is probably a lot of code to, you know, create all this stuff. It's actually not. So the cool thing that I wanted to look at in this stream is something called Flask Admin. And so Flask Admin is a plugin for the Flask web application framework. And I'll put links in the description below to all these little pages that I mentioned. So like I said, Flask is this really nice little simple web app. Like you can see right here in 4 or 5 lines of code, that's a basic web app that it's got up. But Flask Admin is a plugin for it that basically can talk to a database and build a simple interface like you see here, you know, like list all of the values, list all the rows inside of your database table, let you add new rows, let you update rows, delete things. It actually is generating this entire web page right here. I didn't write any of this code. I just wrote literally one line that points it at the model class I created in the last video and just said, hey, go build this web page, and it did its thing. And same exact thing for this sensor reading page right here. This is just the Flask admin's kind of default view of the sensor reading table that we had in the last video. And then the main page here, the home page, I've actually customized this one a little bit to add some of this stuff here, but I'll show you how I did this. But that's the really powerful thing about this Flask admin plugin is that it's made to build up these CRUD type interfaces for your database. Because when you're building a web application, you know, you've probably got some user facing part of it where like it's what people are going to interact with and it has all your business logic and all that stuff. But then there's probably an admin side to it, an administrative side, where you need to go in and maybe have some way to update your database or look at the values in it. You know, things that maybe you haven't built out into some real fancy and slick user-facing thing. You just want some basic control over your database. And that's what Flask Admin does. And I haven't really used Flask Admin much, so that's why I wanted to do this in this stream, is to just kind of play with it and see how it works. And they actually seem to have some pretty good documentation, so they just give you some getting started info right here, and it's pretty easy, just like Flask, to use it. You just have to add a little bit of boilerplate stuff and point it at your views and things, and it's ready to go. So let's jump back to the Pi, and I'm going to quit out of the things that I was running. So I was running both the web application and my little Dht read.py, which is exactly what I created in the last video. So that's just a script that reads my sensors and writes them to my database. And I'm going to go jump up a few directories here because we're going to start from scratch. So I have a part 3 directory that I created. And this just has all the code from part 2. So we'll just start with part 2's code and go from there to start modifying it and adding this kind of web application layer to it. So to get started, I think we can just kind of start with Flask Admin. I was just going to use its kind of quick start or getting started kind of page here where it says, okay, the first step, you create a Flask application, you create this admin object, and then you have to add views to it. And the views are basically a view of a database table, or a view if you're using like an ORM layer, like the Pewee ORM that we're using. There's special model view classes here that they have. And if you basically just add these model views to your admin object, and you kind of have to point it at, okay, you know, for each of my database tables or each of my modeled items in the Pewee ORM, there needs to be a separate model view for it. But this is really all the magic that you need to do for it to build out that entire interface. So I can point it at my DHT sensor configuration model and my sensor reading model as 2 different views, and it'll go and build all that code automatically for me. So that's really cool, really powerful. You know, I don't need to worry about writing that stuff. And it looks pretty nice, as you saw before. You know, this is like a little Bootstrap based, and I've used Bootstrap before in some of the previous videos, and so it's nice that it does all this stuff. And it's, you know, maybe it's not something I would necessarily like ship to end users. You're probably going to want to customize things a lot, but there are lots of hooks and ways you can modify this admin interface. And again, it's the admin interface, so it's not really, necessarily like something you're going to ship to people. And again, like this whole example is really more of a toy example. So there's no authentication, there's no security here. Like there's no password to get into this. Anyone can just go and start accessing the database. So again, it's more in the context of like you building something for yourself to run on your network, but not to be like, some outside thing that other people are accessing and stuff like that. So, okay, so I've got my part 3 folder. I have the part 2 code, and I'm going to open up this in my text editor right here. So, just a refresh from part 2, we created this model.py, which uses the PWORM library, and it just creates, basically this DHT sensor model and a sensor reading model. And then each of these get created by PWORM as tables in a SQLite database. And then the PWORM gives you all this like query capability and easy ways to add and update data inside of there. And then I had this DHT read.py script that basically just used that data model I just mentioned. It defined a couple sensors here and then just goes into a loop, and every 2 seconds it reads the new values from my sensors and stores them back into my database. So using this add reading call right here. So, nothing's too changed or too different from that. So to get started then with SQL or with Flask and Flask Admin, I first need to install it. And they kind of mention in the documentation here what you need to do. So again, because I'm using Python 3, I'm going to use the pip3 command for all of this. And you just have to install a few dependencies. So sudo pip3 install flask-admin, and then WTF-pw, which sounds a little weird, but this is basically the WTF forms, which is like a nice little Flask form, like HTML form creation library, and it's specific to the PWORM. And I do this because I'm using the PWORM, and Flask Admin actually knows how to natively talk to the model objects in PWORM. But in order to do that, it has to have this little library installed. So it's just a dependency that you need to do. So I'll run this, and it's going to tell me I already have these installed. But for you, it's probably going to go through and do the installation for these. So, okay, so I've installed everything. So let's just start with the basic kind of getting started code with the Flask Admin library here. And I'm going to make a few tweaks as I go because I'm actually, I'm using the latest version of Flask. I think it's 0.11, I want to say. Let's see. Yeah, 0.11x. And it actually made a pretty big change in how you run Flask applications. So in the past, you kind of embedded inside your Flask app how its development server should run. But now they've pulled that out, and there's a whole separate command line tool that you run to invoke the little development web server with Flask. And I'll show you what I mean in a second, but it did kind of change things. So if you've used Flask before, just be aware that things have changed very recently in how it runs. So, okay, so I've installed my libraries. Let's go in and I'm going to create a webapp.py file inside of here. So we'll say my fingers are off the keys. There we go, webapp.py. And inside of here, let's just paste in the boilerplate code that the Flask Admin library kind of gives us here. So nothing too crazy or different here. One thing I am going to do, I'm going to remove this app.run, and this is because of this Flask change I just mentioned. I had this in before, and I noticed it causes some weird bugs with the new way that Flask works. So just be aware, if you see an app.run, your Flask app is probably meant to run with an older version of Flask. I'm also going to change the name here. We'll say SQLite sensors. So this is just a name it puts in the page that it renders, but that's nothing too crazy for us to change. And I'll keep everything else the same. The template mode, this is just you can actually change this between Bootstrap 2 or Bootstrap 3 apparently, and that just changes what version of the Bootstrap library it uses for rendering. Stick with 3. It's kind of the nice looking one, the more modern one. So okay, so let's save that. And then to run this as a Flask application, so I'm in the same directory, this is where it's changed a lot with Flask. So you actually have to set an environment variable, and there are a couple ways you can do it. I'm just going to do it all on one command line here, and you point it at the file that has your Flask application, so webapp.py, and then you want to run the Flask command. And actually, I'll show you here. If I just run Flask alone, I can run --help. and it's going to print out some usage information. So it tells you this is the utility for Flask, and it has a run command and a shell command. And the run command is actually what we want, and you can even get help on that if you do flask run -- help. Then we'll see it gives you a bunch of options here. So this is one big change now. You know, when you use the Flask development server, you have to use this Flask command and the Flask run command specifically. And then if you want to specify separate options, like if you want a multi-threaded development server, you have to specify it on the command line. Whereas in the past, you would actually embed that in your Flask app code. You'd do like an app.run and send it a special command line parameter, but no longer do you do that stuff. So just be aware, that's where you change stuff. And also it's where you can change like the host that your web app is listening on, or the port number that it's listening on. And by default, all your web apps listen on only local host, which means you'd have to be on the Raspberry Pi in order to access that web page. But I'll show you, you can send a 0.0.0.0 as a host value, and then that'll make it listen on any port or any network interface so that you can access it from any other machine on your network, like the computer that I'm running this from. So that's what I want to do. But and remember, that magic thing is you have to set this Flask app environment variable. Otherwise, the Flask run command doesn't know how to, like, which script to run. So you have to explicitly do this. And then so I'm going to run the Flask command and then the run sub command inside of there. And then here's where I'm actually going to specify that -- host equals 0.0.0.0. So 4 zeros. That just means listen on any network interface, not just localhost. And that should be everything that I need to do. So we'll run this, and it should say, okay, hey, I'm listening on 0.0.0, and port 5000 is kind of the default here. So this looks good. It didn't fail, nothing messed up. Now if I go back to my Pi here, and if I hit enter, you'll basically see there's nothing that shows up. And that's because by default, Flask Admin listens on the /admin path. So that's what you need to hit here. And you can see there's really nothing here, and that's because I haven't enabled anything yet. But it's cool, like it's built up this interface so far, and it, you know, changed the SQLite sensors here and has that in. So that's cool. Now there's one thing I wanted to change though. Like since I'm gonna use Flask Admin to build my entire application, which is probably not something you really want to do, because again, this is really just meant for administrative interfaces. But for me, from just making a little app for myself, I think this is okay. But you actually can change the URL that this is hosted under. So, you know, right now it's under this /admin, but if I put in a little parameter here, if I say URL equals just /, this will actually change the URL that it listens on. So if I go back here, and I actually need to hit Control-C a few times to stop the Flask server, and just keep hitting Control-C until it stops. Like sometimes it gets buried into these message loops, and it, you know, it takes a little while for it to run. So okay, let's run our app again. And now I should hopefully okay, yeah, so it's running. Now if I go to just Raspberry Pi :5000, and you might not be able to access Raspberry Pi on your network. So that's because my router is resolving this host name into the IP address. If this doesn't work, then you need to look up the IP address on your Raspberry Pi. You can just use the ifconfig command, and this is going to tell you here's the IP address of your Raspberry Pi. So use that if you're not sure what it is. But now if I hit this under /, hey, now it loads up. I didn't have to use that admin path. And so if I try to go to admin, you actually get an error that it's not there. So, okay, so that's cool. So that's how I'll kind of build out my app, is using that. Okay, so now the big thing, the actual meat of using Flask Admin, you know, where it really shines is when you add views to this admin object. And so you need to add an instance of a model view class. And a model view is basically a view of some model from an ORM, an object relational mapper. And it's different for each ORM. So this example here is showing for the SQL Alchemy, and SQL Alchemy is a Flask, or SQL Alchemy is an ORM for Python, an object relational mapper, kind of like Pee-wee ORM, but a lot more advanced. It has a lot more options. It's been around for a long time. And remember, I used the Pee-wee ORM because it was pretty simple and easy to get started with, and does exactly what I need. So, you know, I was keeping it simple. Luckily, though, Flask Admin supports Pee-wee ORM, and it's kind of hidden in the documentation here. You have to go into using a different database backend. And then if you scroll down a little ways, they mention, so Pee-wee ORM. So here we go. And so this mentions how in order to use it, you need to install a few packages like that WTF Pewee package. So that's why I installed it, if you're curious. And otherwise, it's pretty straightforward and easy to use. Now they point you towards an example file, and so this is good to look at. And it's a very simple example file. I like this example a lot, and actually I want to remind myself to put a link in here. So I'm going to open this in a separate page. Oh, I already had it open over here. So, but this is the example file, and so this is pretty much kind of what we need to do. So I need to import the Pewee ORM model view class into my code. So I'm going to add this line up here. And then something that the documentation doesn't really tell you until you do it and it doesn't work, you have to set this secret key value in your Flask application. And I believe this is used to secure or maybe even encrypt some context, like some session variable, session state that a lot of web applications manage. So in practice, you're supposed to set this to like some random value, like a password. But I'm just going to set it to some string here because, again, I'm not building something that's secure. This is just something for me to play with. So hey, we'll use MOSFET as a value. But you do have to set this, or else I noticed the Pewee ORM model view class won't let you save objects. It actually throws an error that says, hey, you need a secret key set. So just an FYI, you do have to set that. But then once I've imported that, we're pretty close to just using the standard SQL or standard Flask admin stuff. There's one other little gotcha, this check same thread equals false. This is on the SQLite database class from Pewee ORM. And so this is something, if I go into my model object, this is where I create that SQL database object, and it's going to read this dht.db that's in the same directory. And I want to add this parameter here. Now, I don't have to add this. This just means that open this SQLite database connection and support multiple threads accessing it. Because basically, if I didn't have this and my Flask web application had multiple threads running trying to access the database, SQLite could start throwing errors or could start saying, hey, I'm not expecting multiple threads to access me. And like I had mentioned in previous videos, SQLite database, it's not designed to be the back end for like high load web services and things like that. So, if it's just you accessing your data on your network, maybe from a few devices, it's probably okay. If it's you building something that hundreds and thousands of people are going to use, don't use SQLite as your backend. You need to use a real database engine. Like I wouldn't say real database engine, a database engine built for high load like that, like maybe MySQL or PostgreSQL. And maybe in a future video in this series, I might look at switching to one of those engines. But anyways, long story short, we need to add this little parameter here just to prevent any issues with multiple threads accessing this. So, okay, so we're pretty close now. So now I've got this model view class imported and it's specific to the Pewee ORM. So now I can go back to the Flask, Flask Admin quick start here. And so let's go back to this intro. And so now I want to add a view. And for each of my views, basically, they each map to the models in my Pewee ORM class. So I have a model for my DHT sensor configuration and for my sensor readings. So each of these models can have a separate model view built for it, and then Flask Admin will build out the whole interface like you saw before for this. So let's do that. Let's just call my admin.addView, and then I need to create a model view instance, and that's this guy up here. And for the Pewee ORM model view, you just need to give it your model class name, like DHT sensor or sensor reading. And in order to do that, I need to import my model class. And I can do this because this model.py is in the same directory as web app. So this import statement is going to import model.py. And then I can access anything inside of model.py just with model dot. So I can say, okay, model.dht sensor. This could be one view. And then let's do another view for my sensor reading class. So this is the other model that I have inside of here. So let's do that. And this DHT data object, this isn't a model. So it's only things that inherit from the Pewee ORM model object. This DHT data class was like a data access layer that I had created before. So it has like a bunch of high level functions that go query the database for me. So this is not something that Flask Admin knows how to turn into like a web page, basically. It only knows how to turn Pewee ORM models into web pages. So, okay, cool. So let's save that. And I think that's all I need to do. Yeah, I just call that add view, and that should be it. So let's go back and run our web application. So I'm just gonna cancel out of this a couple times and do this run again. And let's see what happens. Okay, so we'll access our web page. And so now I load it up, and hey, notice this. At the top, I have a couple new kind of high-level menu items. So if I click this DHT sensor, look at this. It's reading my database, and it built out that whole interface. Like, that's pretty cool. I have to hand it to the Flask Admin folks that, you know, just 2 lines of code. And it's also PWORM, you know, like that's doing a ton of the work behind the scenes here. But that's pretty cool that just a couple lines of code, it's built out this whole interface. It's showing me, you know, these are the readings that are inside of your database table here. And if I want, I can go in and like, let's create a new row, and we'll say this is DHT3, and this is a type 22 on pin, how about 23? Or how about, I might be using pin 23. So let's say pin 17, for example. And I click save, and then it's gonna reload, and you can see, hey, look at this. There's the new row that I created. If I want, I can delete this row, and that's, you know, are you sure? Yep, let's delete that row. So this is cool. I'm going through and modifying my database like with almost no code at all. So that's that half done. Like in the example that I showed earlier, that's it as far as all I did to get these 2 little things at the top. So that's pretty cool and pretty handy. So okay, so let's see what we can do for this kind of home page, or the default page it lands on. Because as you saw in the example at the start, I had like some charts and some fancy stuff inside of here. And so if we go back to the Flask admin documentation, they mentioned the next little section here is adding content to the index page. And so that's where you can actually plug in your own HTML or your own code that should render inside of that page. And it's pretty cool. You can just create a template basically. So you create a template folder, or templates folder, which is a Flask convention, and then inside of there you create an admin folder and an index.html, and then you put this little kind of boilerplate block of code inside of there to start with, and then you can add more code to it. So let's do that. So let's go in and create a templates directory inside of my directory, my part 3 directory. So we'll say templates, and this is just a Flask thing. Like this is where Flask expects all of your templates to be stored in a templates directory. And then inside of here, I need to make an admin folder, and this is the Flask admin convention where it looks for templates inside of the admin folder of the templates folder. And then I need to create a file index.html, like it mentions, and I'm just going to copy in the boilerplate that they have here. So let's paste that, and instead of hello world, let's just do, how about like an H1 SQLite sensor storage part 3. We'll do that. Okay, so we'll save that. And this template syntax, it uses, this is a Flask thing, it uses something called Jinja2, and I'll put a link in here to the documentation for this. There's a lot of stuff you can do with this. So, you know, a template is basically like code that writes code. And so the code inside of here is this Jinja syntax where it's Python-like, but usually you'll see like this curly brace %. That basically means, hey, some Jinja code goes inside of here. So like block body is a Jinja thing. And then anything outside of these braces is actually code that's emitted. So this is basically saying, hey, define this block called body, and inside of there, throw whatever code is inside of here. And, you know, I could have like foo and bar. Oh, my editor's trying to outsmart me. You know, I can have foo or bar or something inside of here. And it's just going to take whatever text is inside of here and put it inside of this body block. And I'll show you, it'll make a little more sense if we look at the source code for what happens here. But that's what's going on here. It's basically the Jinja template is generating HTML. And right now there's not much logic, like it's just a fixed H1 header that I'm putting inside of here. But we'll see, I'll put in more code here and it'll hopefully make a little more sense as we go. So let's restart our server and see what happens now when I hit the main page. So now I go to this page and hey, look at that, SQLite sensor storage part 3. So that's kind of showing me, you know, here's my H1, my header for this. So cool. Okay, so this is where I can start to put some code inside of here if I want to, you know, start maybe rendering like the last few sensor readings or something like that. So to start with, I was thinking, let's take some code from a previous video. So in the Pi Internet Things video series, I basically built a little web app that rendered DHT sensor data actually kind of in real time. And we won't do the real-time stuff here, but I wanted to just use kind of the basic template that I built for that, and we'll use that as an example. So I'm just going to copy out some of the code that I put inside of here. So like this is kind of the main body of my my app. So I created this little Jumbotron class, and then it has some rows and things inside here. You know, I'll put a link in the description below. Go back to this video series if you're curious. We go through like using Bootstrap library and how to, you know, do basic things with that. And so that's all I'm doing, is just using some of that code as a little quick, faster kind of start here, so I don't have to recreate it all myself. So okay, and let's fix some of the spacing here. Let's see, there we go. So we'll do that. Okay, so this block body, so this is a Flask Admin specific thing. Like, you might be wondering, you know, how do I know what this block body is? So if I go back to the Flask Admin documentation here, and it's kind of buried down a little bit further. Let me see. It's under the customizing your views, I want to say. Yeah, overriding the built-in templates. So this available template blocks. This is telling me certain blocks in templates that I can define if I want to plug in my code to different spots. Because if I go back to the web page, so like, you know, here's the web page that the Flask Admin library generated for me. If I view the source for this thing, let's see, where did they put that? Oh yeah, there we go, view source. So, you know, all of this HTML is generated by Flask Admin, but there are places where it can insert special code, you know, like if I have my own code that I want to put inside of here. And so that's actually, you can see this H1 SQLite sensor storage part 3, that's where my code, well, previously, before I pasted all of this in, let me go back, you know, that's where this code is coming from. So basically this block body is being inserted right here. And so, you know, the rest of the code above here is all generated by Flask Admin, because you can see, like, this is where it's building that little menu bar, and it has, you know, the DHT sensor and then the sensor reading things at the top. So it's cool. I don't have to worry about building all that stuff. But if I do want to put in my own code here, this is kind of where it puts it, in this little block body part. And then, so back to this list, there are other parts that you can plug into. So there's, like, you know, a head section if you want to put things up in the head portion of the page. So that would be like, you know, up here, which is usually where you import like CSS files and JavaScript. And you can see they're importing, like, here's the Bootstrap library that it includes in there. So it's already importing some stuff itself. But if you need to plug in your own stuff, you can add a block head and then put in your lines there. And there's the tail section is a useful one, because it's a section that comes after the body in the document. And so I don't have anything there in my code right now, but if I wanted to have some code that comes after the body, you know, like right down here, I could insert it there. And that's a useful spot if you need, like, you know, for example, right here, they're loading a bunch of JavaScript. And if I wanted to plug in my own JavaScript files, I could put them down in that tail location. So we'll come back to that in a second here. But okay, so yes, let's go back to putting in this boilerplate code that I pulled out from, you know, a previous video, and we'll just kind of fix up the formatting a little bit there. It's not perfect, but that's fine. So okay, so let's change this around. So this Jumbotron thing, this is just a Bootstrap thing. It just makes a fancy little header at the top. So let's just say SQLite storage, or SQLite sensor storage part 3. And we'll just say, you know, using a SQLite database to configure and store sensor data. How about that? So that sounds good. And then after this, it's going to make, this is another Bootstrap thing. So Bootstrap has this whole grid system. And so this has a row with a couple columns of data inside of it. And I'm just going to delete out all the columns except for one. Oops, I deleted too much stuff there. So yeah, let's delete these out. And then, so we'll just have one column, and I'm going to increase the size a little bit. So we'll say this is 5 Bootstrap units long. In a Bootstrap row, there are 12 units total. So you can have, you know, like 2 columns that are 6 units long, or in this case, I just have 1 column that's 5 units long. This will make more sense from, once I start to add more code to this. But for now, so, in the code that I took this from, it was just rendering 1 chart for 1 sensor that was fixed ahead of time. Let's just save this, and there's no code in here right now to render that chart. Like, there's this canvas element, but it's going to be empty. And we'll come back and we'll add this in a second, but I just want to save this, and let's just see how this changes when we render the template now. So I'm going to restart the server, and then hit my web page again. And so now I should see, okay, so you can see here's this kind of Jumbotron thing, which gives you this fancy, big, pretty looking header thing. And then here's the little column that has my DHT sensor in here. So there's nothing there yet. So what I wanted to do now is basically for every sensor configured in my database, and so if I go, to that DHT sensor model view here, so I have 2 sensors that are defined. On my home page here, I want to have a chart for each of those sensors. Now is where it gets interesting, because inside of my template here, I need to actually generate code based on state in my database. So I need to query my database and figure out, okay, how many sensors do you have? I need to loop through each of those and then build, one of these div class column MD5, with a header inside of here. I need 2 instances of these, like an instance of this for each of the sensors configured in my database. And so I'll show you how we can do this. It's actually not too complex. So there's a little bit of setup that I need to do first, though. In my web app, I need to store my database model access class. So I'm going to store it in the config. So in this app.config, it's a dictionary that you can just throw things into. And the nice thing is your templates, like my index.html template, can access anything inside of this config dictionary. And so if I added like a model object, and one thing I learned, apparently everything has to be uppercase that goes into this config thing, or else it's not accessible. I can add a model object in here, and so in my model class that I defined before, I have this DHT data class, which has all kinds of functions like this get sensors function. And if I call get sensors, it returns back a list of all the sensors by querying the database. And that's exactly what I want to do in my template here. So I need to get that object down to my template, and I can do that by storing it in my config. And this is maybe not the best way to store your database state. Usually databases have like connections that are open to them, and you might not want to jam that into global config like this, but it's easy and it works. And I think for this kind of a simple application, it's not a big problem. So that's why I'm doing it this way. So I'll store in my config dictionary. I'll create a DHT, let me see what I called this thing. It was a DHT data object. So let's just create a DHT data object, and we'll just store it in there as my model. And so now in my template, I can actually access this DHT data object, and it's pretty simple and straightforward. So what I want to do, I want to loop through all of the sensors, and the way you do that in the Jinja template syntax, they have a for command, and it's very similar to Python. So I can say like for sensor in, and here's how I access that configuration. So I can say config.model. And so now config.model is an instance of this DHT data object, and that's because I created it and stored it there in this line. And so now I can call any function on this DHT data object, like I can call get sensors. So I'm going to do that. I'll call the get sensors function on this. This looks so similar to Python. You might think like, oh, I can just throw any Python in here. You can't. It's similar to Python, but it's not exactly Python. You can call like Python functions and things inside of here, but the syntax is sometimes a little bit different. So just be aware, this is not just a general throw Python code inside these curly brace things. It follows the Jinja syntax. And so I have the Jinja docs open because the syntax differs in a few ways from normal Python. So I find myself having to refer to it because I don't use it a whole lot. And then I do also have to tell it when it's done with this for loop. So you need to do this end for block down at the end. And so what it's going to do, and I'll indent the code to make it a little more obvious, it's basically, this is going to loop through all of the results that it gets back from this get sensors function, and it's going to emit this code for each of those instances that it gets back. So, if there are 2 things in my database, like I saw right here, and I have 2 rows inside of here, it's going to emit 2 of these div class column MD5 blocks inside of here. Now I can modify each of these. I can actually pull out attributes on each of the sensor objects that it's looping through inside of here. And the way you can do that, you can use this inline syntax with Jinja, where you use double curly braces. And I've used this before in some of the Flask stuff that I did in previous videos. But this basically means that, now I can evaluate some expression. And so like my sensor object that's created up here in the for loop, I can access anything on it. And this sensor object is an instance of the sensor model that I have, because I'm just using, the pwe orm, this select statement. So it's just going to return back a list of all these sensor objects. And each of these objects has a name, DHT type, and a pin field on it. So let's use the name field on here to just print out the name of each of my sensors. So let's just save this. I'm not going to add anything else. So in theory now, I should see 2 blocks, one with DHT1 as the name, and another with DHT2 as the name inside of there. So okay, so let's stop the server and then start it again. And let's go back and see what happened. I'm going to go back to the root page. And so, hey, look at that. So now I have DHT1 and DHT2. And if I go back, if I view the source for this, now we can actually see, here is where that Jumbotron thing is that, is in our template. And then here is the thing right below it, the container. And notice that it has 2 of these div class column MD5s in here. So, there's the first one, and there's DHT1, the name that it got, and DHT2, the name of the other sensor that it got in there. So that's pretty cool. This template is just defining, here's what you should do with each of the sensors that you get back from the database, and how to turn those into HTML code that can be rendered and show different things inside of here. So okay, so that's cool. Now there's a little bit of an extra thing I need to do, because each of these has a chart associated with it, and each of these charts needs a unique ID, so that the chart.js library, which is what I used in the video that I took this code from, the chart.js library needs a unique ID, because it needs to be told like, hey, this is the canvas object for this specific chart, so go render your chart inside of there. So to do that, what I wanted to do is I wanted to say, let's create a name, let's say chart underscore, and then I'm going to use the curly braces. So I'm going to tell Jinja like, hey, evaluate an expression. And I'm going to use sensor.id. And so this, if you remember back from the previous video, we saw that pwe orm, even though my model object doesn't define this ID field, it creates one automatically, and it just sets it to a number, like a unique numeric value. And that's good, because since it's a unique number, I can just use that in my ID, and I'll know that, chart underscore 1 refers to whatever is my first sensor in the database, and chart underscore 2 is maybe the second sensor inside of here. So that's what I want to do here, to give it kind of a unique value that I can reference later. So, I'll just save that, and we can just look at the code real quick that it generates. So I'll run the app again, and then let's hit the web page, and we should see nothing looks different on the web page. But if I look at the source here, we should see that it's a little bit different. And so now notice this. So the ID of my first one is chart underscore 1, and the ID of my second one is chart underscore 2. So cool. So now I can uniquely identify each of these charts. Okay, so now the next step, to actually get the charts to work, I'm going to use this chart.js, which is the library I used in the previous, that Pi Internet Things video series. So, go back and watch those videos. And, this is basically where I build the chart inside of here, is you just use this chart library. Now, to do this, I need to put this in a script tag that ideally is kind of at the end of my body. I could put it in my template. Like, I could probably put it down here if I wanted. But I was thinking, Flask Admin, it has a block specifically for this kind of a thing. So it mentions, this tail, which is kind of the part below your main content here. So let's do that. Let's put a new block inside of here. And so we'll say block tail. And then you also have to do the end block for this. So oops, end block. And okay, so now I can put in, a spot that comes after this body code. And this is a good place to put like JavaScript that I want to load. So let's put a script in here to load that chart.js from a CDN, and I'm doing this for simplicity. You know, I could copy this into my static assets folder for Flask, but it gets really complicated. So let's just throw this in. This is basically a little CDN that someone else is hosting this file and allows people to access it. So, you know, as long as I put this URL in here, then I should be able to access my chart.js. And then the next thing I wanted to do is add a script block where I can put in my own JavaScript code. And in here, I'm going to use jQuery because Flask Admin uses Bootstrap, and Bootstrap requires jQuery, although I don't think it necessarily requires the real jQuery library. I think it has like its own little like mini version of jQuery, but it's similar enough to jQuery that we can use it. So jQuery has this ready function that's handy in that it'll call some code whenever the web page is finished loading. Because web pages load asynchronously, you know, it would be bad if I started to run some JavaScript code that depended on chart.js. If the chart.js line above here didn't finish loading, you know, you'd start running into errors. You'd be like, your JavaScript code would say, hey, you're trying to call this chart function that's not defined yet. Like, what are you doing? So I need to basically say, hey, wait until everything is loaded, now run my code. And that's what this document.ready thing does. And so you pass it a function here, and you can define that function inline because JavaScript is all fancy like that. So that's what I'm going to do here. Very common convention. Everyone does this in JavaScript. So if you see this, that's kind of what this means. Okay, so now at this point, I can start plugging in the chart objects here. So if I go back to my PyInternetThings code that, you know, previously I just grabbed the HTML code here. Now let's grab some of the JavaScript code. So this is how we define a chart. And luckily for this example, I use the same sensor, the DHT sensor. So this is defining a chart with two data sets on it, one for the temperature and another for the humidity inside of it. So let's just take this code and let's use that inside of our code. Now I'm going to do something a little different. I'm going to actually define a function. Let's say build Dht Chart, because remember, I don't know how many charts I'm going to build ahead of time. Like, not until I query the database and get back the number of sensors do I know that, you know, oh, there are 2 charts or 1 chart or maybe 0 charts or 100 charts. So I'm going to build a function that I can pass in like the name of a chart, like maybe, you know, the names that I defined up here, and then it can go and like set it up and add those data sets and things to it. So that's what I'm going to do. I'm just going to define this little function here, and I need to know at least the ID of my chart. So let's put that as a parameter, and then I'm just going to paste in the code that I had copied out. So, and we'll fix up the formatting here. So here's where, you know, right now it's hard-coded to use something with an ID of Dht Chart, but it's not going to work for us because, you know, we're generating our IDs up ahead of time here. So, you know, I'm going to worry about that in a second, but for now I'm just going to say, you know, the caller better pass in an ID that works. So we'll do that, and then it's going to create a chart. It's going to make a line chart with 2 data sets inside of it. Right now there's no data inside of these data sets, so there's nothing in the labels, nothing in the data. We'll come back to this in a second though. So okay, so I've got this function, and as long as I call it and give it an ID, it can build a chart based on that. So that's cool. So okay, now in my document.ready, so now once all my code is loaded, what do we do? So I want to do the same thing. I want to loop through all of my sensors and call build chart for each of those. And that's the cool thing. Like, remember, I'm in a template file here. At any point, I can break into this Jinja syntax and have it generate some code, even if it's JavaScript code that's embedded inside my HTML code that's embedded inside my template code here. So, you know, there are a couple levels of inception going on here, but it's pretty powerful because, you know, you're generating code and it just reduces the complexity of the code that you need to write. So, okay, so inside of this code, I'm going to generate some JavaScript code. So I actually, you know, let's console.log so that I know, like, this will just print out to the debug console the name of each of my sensors. So we'll say, and I need to do this as a string. And so I'm going to do, you know, create a string, and then I jump into that Jinja expression syntax because I want to pull something out of this sensor object, and I want to say sensor.name. So, okay, so that's going to emit a console.log call for each of my sensors. And then let's also call my build Dht Chart function here. And I need to give it the ID. And so remember, you know, I generated these as chart underscore sensor.id inside of here. So, okay, so let's save that. And now let's stop our server and restart it real quick and do that. And then we'll go back and I'm going to open up the console. There we go. So we should hopefully see, yeah, there we go. And then let's reload the page. And uh-oh, get context is undefined. So let's see. Okay, so, but you can notice here it did print out DHT1, but something went wrong, probably in my Dht Chart function here. So something is bad about this. So let's see, and you can actually click this and it's going to point out the line that it's failing on. And so I'm betting that the ID that I passed in is incorrect here. So cannot read property undefined. So, okay, yeah, so can't find this. So let's go back and let's see if, oh, I see the problem here. So I just scrolled down. So this is the code that was generated by my template right here. So, you know, this template generated this block of code right here. And let me scroll this over a little more so you can see it. Oops, there we go. And so you can see here, you know, the console.log function, that looks okay. It's just logging a string. My build Dht chart, it's passing in chart_1, but that's not how you identify an ID in HTML. So it's how you define the ID, but when I want to reference this ID, you actually have to put a pound sign in front of it. And so I forgot to do that here. So I actually want to do pound chart_, then the sensor ID. So, okay, so let's save that and let's rerun our application here. And then it's running. Okay, now let's reload the page. And okay, cool. So I don't see anything wrong there. And okay, so we print out both these. Okay, cool. So now the chart's not rendering yet because I haven't given it any data, but there should be these chart objects inside of there so far. So, okay, so far so good. You know, I've got both of my sensors and I've got my charts inside of here. Now to pass these charts the data, you know, again, I'm not having this update in real time. So what I was thinking in this build Dht chart function, I'm just going to pass it the list of all the recent sensor readings basically. So let's modify this function slightly. So let's have it take in the list of labels. And this is basically going to be the values on the x-axis that are down below. And so let's, instead of sending an empty array, we're going to just use the labels argument that I passed in here. And then let's also have it take in the humidity data and the temperature data. So this should just be a list of the humidity readings and the temperature readings that it should render in the chart. And so I'm going to put those down here also. So instead of an empty array, it's going to call, or it's going to use the temperature parameter, and same thing for humidity down here. And now let's just put in some dummy data for now. So, you know, now my build Dht chart function, it needs to take a few more parameters. So I need to pass in the list of labels. So for now, let's just say 1, 2, 3. And then it needs to take humidity. So let's do like 0, 1, 2, and then another list with my temperature data. So how about 3, 4, 5, something like that. So, you know, these aren't getting pulled from the database. It's just hard-coded inside of here. But let's just double check. Let's run this, make sure that our charts should now render with some data. So, okay, that's running. And if I refresh the page, cool. Okay, now we see our charts are starting to render with some data inside of here. So you can see like there's 1, 2, and 3. These are the labels for each of the charts. And then there's one data series here that has 0, 1, 2, and then the next one has 3, 4, 5 as values in here. So, okay, cool. We're getting pretty close. You know, now I need to figure out for each of these sensors, I need to get these values of like, you know, the list of labels and the list of temperature and humidity values that we read inside of here. And for that, I need to go back to the database. So I was kind of thinking, you know, now I need to think of what do I want to show on this web page. And I think maybe the easiest thing would be, let's show the last 30 readings, because I take a reading every 2 seconds. And so that'll basically show me a minute worth of data inside of here. So I need some way to get, you know, for each of these sensors, the last minute of data effectively for each of these. And so if we go back and if we look at our sensor reading table here, and that's the handy thing, you know, this is the nice little interface that Flask Admin built for us. You know, we can go and see the way I stored this data. I have a name field with the name of my sensor, and then humidity for the humidity data, and temperature for the temperature data. And then I have the time that it was taken and the actual value at that point in time. So, for the labels, I know that I'm just going to use the time as my label on the x-axis. For the values, I know I just need the value column here. So I need a way to go through and query my database and say, okay, for a given sensor name like DHT1, or maybe even just like the name of my sensor reading like DHT1 humidity, go through and grab the 30 most recent readings from here. And I'll show you, we can do that. We can use the Pewee ORM to do that. So it's got some really nice query capability built into it to go through and select different rows and things like that. So let's go in and let's go to our model.py class, because I have this data access object that I created, and this is a good spot to add a new function that can get like the most recent sensor readings. So let's make a function called getRecentReadings. And let's have this take in like the name of the sensor readings to get. And so this is going to use the name field in our sensor reading table. So if you pass in DHT1 humidity, like this value exactly, then let's have it grab the 30 last or most recent readings for that. So okay, so to do that, then I need to do a query on my sensor reading model, this this Pewee ORM model. And it's pretty easy. So I'm going to do a select query. So I'm just going to select all the rows out of here. Now I'm going to break this up across multiple lines. And Python is a little weird about how it does it. If you're breaking most statements, you have to do a slash and then go on to the next line. But if this is inside of parentheses, then you don't actually have to put a slash in between lines. I'm going to put the slash just to be explicit about it. So that's why, if you see these slashes, because otherwise if I tried to because I want to call another function here, there's like an order by function that they have. This is not valid Python code. You can't break things across lines like that. So you have to put this slash, and now it is valid because it's telling Python, okay, this line continues down here. And this white space doesn't matter. It's going to just ignore that white space. And the way the Pewee ORM kind of works is you chain together a bunch of function calls when you're querying things. So let's see, I think they have a better example in their quick start here, where if I want to, retrieve data, you can basically say, okay, select where, if you want to do some filtering, or they show like, here's a more complex example. So select and then join and then add a where clause. And here you can see they're actually putting these parentheses in here so they can split across lines without having to use those slashes. Okay, so I want to select and I want to filter. So the where clause is what I want, because remember, I only want to select rows that have the name that's been passed into me right here. So that's what I want to do. So I want to say, select where, and the filtering syntax, you basically say your model class, your sensor reading, dot the field that you want to filter on, and so that's the name field, equals, and so they have a real similar syntax to Python, some value, and so that value, I'm just going to, take the name attribute that, the name parameter that was passed into me. So this is going to go through the database and grab every row where the sensor reading name equals the name that was passed into me. So that's good. So we're going to, if I just want DHT1 humidity, I can call this function and pass in DHT1 humidity. If I want DHT2 temperature, I can change the name and it's going to do that. Now I want to get my data in a certain order, because the database, unless I tell it, it might just randomly give me back data. And not necessarily in any special order. And I could sort that data myself in my own code, but it's the kind of thing where that logic doesn't usually make sense to put into your application layer, because the database knows how to sort code. It knows how to do that stuff automatically here. So let's rely on letting the database do that itself. And we'll use some ordering capabilities that it has. So there's an order by that you can use. So order_by. And behind the scenes, this all just turns into SQL queries. And if you go back to the first video, I talked a little bit about some of these. There's an order by statement in SQL. So I can say, okay, order by, so sort my results. And I need to tell it my model and some attribute on it. And so I want to do the time attribute. And so, that's just one of the attributes on here. and I need to tell it which way I want to order it. Do I want to do it in ascending order, like increasing order, so it's going to start with the very first sensor reading, or do I want to go in descending order, where it starts with the most recent reading and goes backwards? And that's actually what I want. And so the syntax is you call this .des descending function on this time attribute of your model in there. So it's a little weird syntax, but just kind of follow me here. And again, because I split this across lines, I got to make sure I do that little slash thingy. Okay, now the last thing, I only want the last 30 of these, and there's actually a .limit function you can use, and you can just pass in if you want, like I want only maybe 2 or 20 or something like that. So I could say 30, and I was kind of thinking, let's make this a parameter and we'll give it a default value, so that way if I ever wanted, I could override this to like more or less readings without having to rewrite this whole function. So we'll, and if I don't care, then it's just going to use 30 as the default in here. So okay, so cool. So this is really all that I need to query the database, and it's going to go and say, okay, grab all of the sensor readings that have a specific name that's been passed into me, and then sort them in descending order, so the most recent one first, and then following that the less recent ones after that, and then limit it to some numbers. So it's only going to grab like the 30 most recent of these values. So okay, so let's save this, and let's go back to our template here. And now, let's see, I'm not going to change anything just yet as far as how I'm building my charts. Let's just log some of this data to see, if I can just make sure that I can call this function. So let's see, let's do a console.log, and we need to build up a string here. Well, actually, I'm just kind of thinking through how I need to explain some of this. So maybe let's not log it just yet. So what needs to happen here? Inside of this loop, I have my sensor object, and so for each of my sensors, this will be set to that sensor, and I can get the name of my sensor, and if I know the name of my sensor, I know for each of my sensors, I'm saving a humidity and a temperature row in my sensor reading. So, there's name of my sensor, space humidity, name of my sensor, space temperature. So each of these I could query individually. And so what I want to do is, I want to query all of the temperature readings and all of the humidity readings for, or at least the recent readings, for each of these sensors inside of here. And I'll show you, it's a little bit funky how I kind of do this. So there's a set command in Jinja where you can basically create a variable, because again, this is not Python code. Like you might think like, oh, hey, I could just say, foo equals my config.model.get readings. You can't do this, unfortunately. So you have to kind of follow the Jinja syntax here. And so I want to create a variable that has the humidity values. So we'll say humidity equals, and we'll come back to filling in what this means in a second. And then I want to do the same thing for temperature. So temperature equals something. And so, okay, so now here I can actually call some code. And so what I want to do, I'm going to call my model object. And so that's, remember, that's this DHT data object that we created before. And so now I can call this get recent readings function on this. So let's do that. And I have to pass in the name that I want to grab from my database reading table. So I know I need to build this value again. So I want to say, I basically need to build a string here that says, my sensor name. So we'll say sensor.name plus, and I'm just going to use string concatenation here in Python. It's maybe not the most efficient way, but this will work. So let's say humidity. So this is basically going to say, okay, my sensor name plus space humidity. And so, if I go back to my database table, you can see, so DHT1, that's the name of my sensor, space humidity. So this should pick up all those rows. And then the same exact thing I want to do for the temperature, but just changing to use the string temperature instead of humidity. So, okay, let's do that. Okay, cool. So this is going to basically create a humidity variable and a temperature variable that I can reference in Jinja code, not in JavaScript. So this is code that's specific to the Jinja templating language. But once I have those, now I can do some Jinja magic, I'll show you, to actually turn this result into like some JavaScript code, or even, for now, let's just log this data. So let's log our humidity data first. And so the way I want to do this is going to get a little funky. I'm going to use this Jinja expression syntax. And they have this thing called a filter, which is a way to take some variable, like this humidity variable, and apply some processing to it. So that's what I'm going to do. And the syntax for this is a little weird. You do humidity pipe character, and then you need to call a special filter. And so if I go back to the Jinja documentation, if I go down to built-in filters, so this talks all about these filters that they have here. And there's this handy filter called the join filter. So what this does is this will convert a list into a string and add a separator to it. And it can even go through and grab an attribute of objects that you're iterating through instead of just assuming you're iterating through strings. And this is actually the syntax that I want to use here. So this is real similar to the join function in Python. Like if you're ever turning a list of numbers into a string with commas in between them, that's what the join function does. And so the join in Jinja is very similar to that. So let's just throw this in. So I'm going to take this humidity value, which is a list that's coming back from this get recent readings result. It's not technically a list, it's an iterable, but as far as Jinja is concerned, it can iterate, it can go through all the attributes there. And it's going to use this join filter, so it's basically going to add a comma and a space to all of these, but maybe I don't even need the space. And then I'm going to tell it that there's a specific attribute because the things inside of this humidity, the result of this get recent readings from my model here, it's going to be instances of this sensor reading object. And so this object has different attributes, and it's really like the value attribute that I want to get out of here, or maybe the time attribute if I wanted the labels, for example. But let's grab the value attribute out of here. So we'll grab that, and then I'm just going to make it a little more clear that, yeah, put a space in there. So that's what's happening here. It's this pipe character says run this little join filter across everything inside of this humidity thing. And so let's just save this. Now in theory, I should see when I run this something logged to the console. Like I should see a comma separated list of all the humidity readings that are logged to the console. Let's see, let's check out what happens. Let me go back to the root page here. And hey, look at this. So there's DHT1, and so that's, for my code here, I'm logging my sensor name, and then right below it, there's this big string here where it's like 60.9, 61, 61. So these are all of my sensor readings. So that's pretty cool. And it'll actually show me, here's the code that was generated for this. So it was grabbing the most recent readings for that sensor inside of here. And same thing for sensor 2. So cool. So that's how I can basically pull this data out. Okay, so we're pretty close here. Like I'm almost ready to fill in. So for my labels here, I want to build a JavaScript list, which is what these brackets do. And then inside of this list, I'm going to do, this fancy little join thing. And so what I'm going to do, it doesn't really matter. Like I want to pull out the time because remember, each of my sensor readings has a time associated with it, and I want that to be the label on the bottom of my chart. And so I could use the humidity or the temperature object, because the way my code works, I log each of the sensors at the same time. So I'm just going to use the time from my humidity here. So let's, do this join, put in a comma here, and then I want to grab the attribute of the time value. And now this is actually a little funky because my times in my database, I'm going to show you, are a little bit different. So if I go back, not there, to this part. So the time in my database is almost a string. I don't think it's actually natively stored as that, but when it comes back from the Pee-wee ORM, it's going to give me a string. And I'll show you actually, like, let's just save this code as is. I'm going to remove this console log, and let's just see what it generates or what it tries to do. Well, it's going to fail, but actually maybe it's not going to be super obvious. So here, how about this? Let's grab what I was going to put inside of here, and let's log this right here. Instead of logging our values, basically we're just going to log our time values. So let's save this, and let's see what this looks like from the console. Because basically what I'm getting at is we need to escape these with quotes, because we need to tell JavaScript that these are strings and not like integers or numbers. inside of here. So if I go back and if I load my web page again, and if I go to my console, see, look at what happened here. So it's printed out, you know, there's like this date as a string, comma, here's the next date value, comma, here's the next date value. If I tried to put this into a JavaScript list, it's gonna fail because JavaScript doesn't know how to interpret this type, but it could know if I put quotes around that this is a string. And so that's what I want to do in my code here. And unfortunately, the syntax for this gets a little ugly. I was hoping that Jinja would have like a quote filter that you could apply to this, but they don't. So you kind of have to hack it in yourself here. And the way you can do that, I can basically say, okay, if I start with a quote, a double quote, and if I end with a double quote here, and then in my join, you know, normally I'm just putting a comma, but let's put in an escape double quote and escape double quote. And so now this should actually do what I want, I think, because although I've actually got to escape these quotes here also. So let's escape the quotes there. I think this is the right syntax. Let's see what happens here in a second. So let's save this. I'm a little worried that it's that my text editor seems to be freaking out about the quotes, but let's see what happens here. Okay, let's run this. And now when I refresh this page, let's see what happens. Okay, okay, cool. So we're getting closer. You can see here's our starting quote. But then it's doing this funky thing here where it's actually doing this HTML escaping on my double quotes that I inserted internally. So again, this is a weird little quirk of Jinja. I need to tell it that that don't do this escaping. And so you can actually chain filters together. So if I put another pipe character and then safe, it's going to run this safe filter, which if you go down here, this is basically saying, you know, mark this as safe, which means don't do any escaping automatically. So that's what I need to do. So now if I save this and if I rerun this, we should see, and I hit the web page again. Now we've basically got double quote, my time value, double quote, comma, double quote, my time value. So now this looks like strings. And so I can actually send this in as a list of strings. So it's, you know, basically this magic template syntax here. I want to copy out, you know, let's pull that out. I'm going to remove this logging line. And okay, so let's put that in here where, okay, so now I'm going to put double quotes, which I don't technically need to escape them anymore because this is not inside of a string that's being console.logged. So, okay, so I've got my double quote to start. Now I've got my Jinja expression start, and then same thing. So I take my humidity list, I run it through this join that's going to add commas and double quotes inside of it. It's going to select out the time attribute. It's going to tell it not to do the escaping, and then it's going to end the expression and add a little double quote at the end. So, okay, so let's save that. And then, you know, let's just keep going. Let's fill in. So I need to send it the list of humidity values and then the list of temperature values. And luckily here, since these are numbers, I don't need to do all this escaping weirdness for it. So, you know, really all I need to do is say, you know, for humidity join, and then just a simple comma, and the attribute here that I want to pull out is my value attribute. And I'll just put some spaces in here because remember, value, it's on this model. You know, each of these things in that humidity list is a sensor reading instance, and so it has a value which is the actual sensor value at that point in time. So let's save that, and then the temperature values are exactly the same, but instead of iterating on the humidity list, let's go through the temperature list inside of here. So okay, so let's save that. That looks like it's okay. I just want to make sure I've got all the code correct. It looks like I'm missing something here. Yeah, missing. Yeah, there we go. I was missing a. And let's just put that on a separate line. Okay, there we go. So that looks okay. And then let's rerun our app. And so now something exciting hopefully will happen. It might explode, or let's see. We'll refresh our page. And hey, look at this. I've actually got some sensor readings here. So you know, it's maybe not super pretty like the labels or the raw dates, but this is showing me here some sensor readings from our database inside of here. So pretty cool. Like we're really close to what I showed at the start here. So okay, so So that's cool. Now there's one thing that's not super obvious just yet. Well, I don't know. Here, maybe I'll make it obvious. So I'm going to go back to my Pi. I'm going to leave the server running, and I'm in a new window. So I'm still connected to my Pi. I'm going to go back up to the part 3 folder that we're working in. And I have that dht read.py, which is, I haven't touched it at all. It's exactly what we did in the previous video. So I'm just going to run it. So let's do sudo python 3 dht read.py. And this is going to read from my database, like which sensors I have configured. And it's going to grab current readings and then save them to the database. Every 2 seconds, it reads the sensors and saves them to the database. So you can see it's doing that right now. And if I blow on one of the sensors, and we should see that it starts to get a higher value. So actually you can see right here, yeah, it just jumped up to 90% on that sensor. So let's refresh our web page. And hey, look at this. You can see here is a 90% reading, which is what we just saw in our database inside of here. So, you know, every time I refresh this page, we're getting more sensor readings here. And you can notice the new sensor readings are actually being added to the left side, because when I queried the database, I said query it in descending order. So this is the most recent sensor reading on the left here. This is the second most recent, and you know, all the way back to, this is the oldest, up to 30. It's only going to grab, you know, the last 30 sensor readings. So one thing I wanted to do is, you know, when you look at a chart like this, you probably expect the most recent reading to be on the right here. So I want to flip these, and there are a couple ways I could do this, but the easiest way to actually do this that I saw, you can actually use this little reverse filter that Jinja has. And so this is a case where, you know, I'm not going to do this in the database because there's not, I'm sure there's a way to do it, but I'm not as familiar with it. You know, I'd need some way to tell SQL, like, grab the X most recent values, but then flip the order that they're returned in. So, you know, this is a case where I think it makes sense in my view to do this reverse function. And I just want to double check that that's really the name of it as the filter. So I'm pretty sure it's called, yeah, reverse, right? So this will reverse them. And again, you know, you can just chain together all these different filters in Jinja using that pipe character. So, okay, so if I save this, now if I restart my oops, I want to keep my DHT read running. This is just going to keep, you know, reading sensor readings and writing them. I want to restart my server now. So let's do that. And then my server is running. And now when I reload the page, oh boy, uh-oh, I did something wrong here. Oh, wow. Let's see. So, okay, so something is way off with the reversing of this. Okay, let me go back. And let's undo what I just did here. So let's see, let's take this out. Let's take this out. Oh, I think what I messed up here is, yeah, I need to put this reverse before my join. So if I do reverse here, because the problem is it tried to reverse the string that join generated, and I don't know what that actually means. It obviously doesn't mean something that I want. So let's cancel this, let's rerun it. And then let's hopefully see what happens here. So, okay, there we go. So now notice, like, you know, these older readings were like up in the hundreds. That's when I blew on the sensor. And then they're slowly falling back down to lower levels. And, you know, this is still running in the background. It's still taking sensor readings here. So I'll blow on the sensor again. Oops. And so now we should see, once it gets a few readings, you know, there, it just took a reading. And now when I reload this page, let's see what happens here. Yeah, check this out. So now my most recent readings here are jumping up into like the 80s and 90s or so. And you know, I can press enter and refresh the page here again in a second. Oops, let me hit enter again. There we go. So you can see, you know, it's showing the most recent readings there. And it's maybe not super obvious, but it's only grabbing like the 30 most recent readings here and rendering them in each of the tables here. So that's it. That's exactly what I wanted to build in this stream here. You know, we went through and created a basic little web application that reads the state and the data from our database. And as you saw, like, because I use this Flask Admin plugin, or I don't even know if I'd call it a plugin. I mean, it's like its own standalone thing. it did almost all of the grunt work of building this web application. So, this is literally our web application code. Like, we're just feeding it our sensor or our model view objects that point at the Pewee ORM model instances that we created in the last video. And then the Flask Admin knows how to build an entire interface around that. And then we plugged in our own little custom interface to say, hey, for this landing page, let's build a chart, because Flask Admin, it has limits. It doesn't know how to build a chart for sensor readings or things like that. You have to plug stuff in to do that yourself. But that's pretty cool. I mean, this is kind of what I wanted to show, that, really driving home the point that all of this data is in the database. So I can have a script like this that runs and gathers sensor readings and writes them to my database, while at the exact same time I've got a web application that's running and using the same data from my database. And without a ton of code and using something like Flask Admin, I can get a nice web interface that lets me add or remove a sensor. Like, let's just try. Let's remove sensor 25 from here, or that sensor. Now when I go back to my home page, look at this. I only see that sensor 1 inside of here because I deleted that sensor. My config doesn't know about it anymore, and so as far as my app is concerned, all that data is gone. Now the data is still technically in the database, so like it still has DHT2 temperature and stuff like that, but it's not going to be adding more of those readings. So like if you notice here in the script that's running and gathering sensor readings, I don't see sensor 2 anymore. After I deleted it, it noticed it because this sensor code that we wrote in the last examples, it's always querying the database. It's looking to see, okay, what sensors do I have now, and gathering the readings from them. And if I wanted, I could add a sensor back in. So let's go back and add, let's see, so I have a pin 18, and I think it was 25 was the other one. Let me double check. Yeah, 25. Okay, so let's add in 25. So if I say, we'll call this DHT foo as my name, and this is a type 22 on pin 25, and we'll say save. And so now let's look at our script, and we should see, hey, look at this, DHT foo, that's the name of my sensor. So it very quickly just picked it up because the state in the database changed. And then let's go back to our home page here, and hey, check that out, DHT foo, and it has like the 4 last readings that it got there. So that's cool. I think that's really powerful. I haven't used Flask Admin until now, but I think I'm going to use this thing in the future for sure, because it's for doing basic database stuff like this where you don't want to write all of this drudge work code. It looks like the way to go. So really powerful thing. If folks have questions, throw them into the chat, but I don't see too many questions right now. So I'll jump back to the main view real quick. And there we go. But otherwise, yeah, so that's what I wanted to show in this video. Yeah, I don't see any questions, so I think we'll just kind of wrap it up. So subscribe to youtube.com/Adafruit, and you can see this video and all kinds of other project videos. Twitch.tv/Adafruit, you can watch me stream these things live, or throughout the whole week. We've got Desk of Lady Ada, Noah and Pedro have layer by layer with all kinds of 3D printing stuff. And then I like to do live streams a couple times a week, so Mondays and Fridays. Now, tomorrow I'm not doing a live stream like I mentioned before. You actually want to tune in to whitehouse.gov/live at 1 p.m. Eastern, and you can watch the White House Maker Champions of Change ceremony, and you might see a familiar face like Lady Ada there. So that'll be really cool to check out tomorrow. So I want to do this stream early on Thursday today. But next week I'll be back. Monday I'll do a little quick look at some Raspberry Pi software, and then Friday next week we'll do, I think I've probably got a 4th part in this series. Like I've kind of been hinting at, we've been using SQLite, but maybe in the 4th part, let's see if we could use like MySQL or another database engine and look at what it takes, because I'm using that Pewee ORM. Is it difficult or is it easy? Maybe it should be kind of easy to hopefully to switch to a different database backend. So that's what I'm thinking for next week. And then maybe next week I might do a 3rd stream. I've been doing a lot of Circuit Playground examples and stuff, so maybe tune in for that. But otherwise, thanks for watching. Subscribe, like, comment, let us know that you like these videos, and we'll keep doing them. It's the feedback kind of keeps us going and lets us know that this is useful stuff for folks. So until then, this is Tony from Adafruit, and I'll see you guys later.